Okay, so let's talk a little bit about factoring using the distributive property. So go ahead and take a second. This is what we've done before. 2a times the quantity 6a plus 8. If I were to distribute this number to here and this one to here, what would be my mystery expression over here? It's yourself, Anthony, on your paper. Okay, so you should have gotten 12a squared plus 16a. So we're kind of going to be doing the inverse of that, which is what we have in everything in mathematics. We have inverses. So 25a squared plus 50a. Can anybody tell me the greatest common factor that 25 and 50 share? Good job. I didn't expect that. I actually put 5a out here. All right, so this is factored, correct? If I were to do this in the reverse, it would be 5a times 5a, which is 25a squared, and 5a times 10 is 50a. But this just happens to be not completely factored. And we're going to talk about that a little bit later. Moving on. Need a quick second? All right, so I'm going to start off with these a little bit slowly, and then we'll go a little bit more quickly. Well, I didn't show you the whole answer. All right, so this is your classic distributive method using, I'm sorry, I need to stop. Are you guys finished? So I'm going to use the classic distribution method. Okay, so why don't I give you guys a second to write down 1, 3, 5, and 7, and then we're going to go through them. You don't have to solve them, just go ahead and write them down. Okay, so if I were to distribute this negative 4w squared, then I would get negative 8w to the what power? This is a 1, so it would be cubed. A negative times a negative is a positive. So what's 9 times 4? 36w to the 8. Good job. That's the simplified answer. Let's do number 5 first before we do number 3. Let's distribute negative 2m to the 6th power. I would get negative 2m to the what power? 8. There's no n to multiply, so I'm just going to bring that n down, and then I'm going to multiply negative 2 to 3, which is negative 6, m to the, good job, you guys are doing awesome. And negative 2 times negative 7 is positive 14, m to the 6th, n to the 5th. Questions on that one? Excellent. So I'm going to go quicker on these two, is that okay? 15x cubed, negative 27x squared, positive 6x. This should all be review, so if it is confusing to you, you might want to stop by and go over it again with me after school. All right, so this one is a little bit more complicated. So I have 2a squared that I'm multiplying by this trinomial. When I do that, I get 2a to the 4th plus 2a cubed b minus 6a squared. Now I'm adding, I'll keep on red. Now I'm adding 4a times this trinomial. So I put an addition sign in, and then I continue to distribute. So I get 28 a to the 4th plus 12 a cubed b. Did I say trinomial? It's not a trinomial. It's a binomial. But I'm not finished there.
Now you gotta add it.
Now I have to combine like terms. So I have 2a to the 4th Do I have any more terms that have an a to the fourth in them? I do. I have a 28 a to the fourth, which makes 30 a to the fourth. I have 2a cubed b. Do I have another a cubed b? I do. I have 12a cubed b, which makes 14a cubed b. And there's nothing for me to combine an a squared with, so I'm just going to write negative 6a squared. Yes?
We weren't supposed to fill it out, right?
Okay, so we're talking about algebra tiles. Before, we had, let me move this down here. We were multiplying a monomial times a binomial, correct? And we came up with an answer like 3x plus 6. So in here I have 3x's plus 6. Can anybody tell me what the binomial would be? For instance, in multiplication, if I want to know what two numbers make 6, I would say what? 2 times 3. So we're doing the same thing with this model. So what would I put on this side? Or if it's a little more clear to you, what would be on this side, on the top? What? We have 6 inside of here. 2 and 3. Let's start with an x. Does this x fit here? Does this x fit here? But it fits a little bit better like this. Right? Now can you see what would go here so I could say this times this equals 1x? A 1. Because 1, you'll see, 1 times x is x. 1 times x is x. 1 times x is x. That makes 3 x's. Now I have 1 times 1 is 1. Okay, see that? So what would go up here? I'm multiplying 3 times x plus 2. This is why this works using an algebra tile model. Try another one. What two numbers, let's put all of them in here first. So can anybody tell me what could go here? What times what makes x squared? So x times x makes x squared. And x times what makes a negative x? Negative 1, and a negative 1, and a negative 1, and a negative 1. So if I were to completely factor this polynomial, it would say x times the quantity x minus 4. So let's use the box method in just about the same way. So write down number 1, 2x plus 10. I'm going to draw it out. Just like in multiplication, where 6 is inside the box, 2 times 3 makes 6. So I'm going to put 2x plus 10 inside the box, and I'm going to figure out what two, I guess it would be a monomial times a binomial, would make, what two would make this product. Sorry, stumbling over my words a little bit there. So what number can I get out of 2x or 10? What do they have in common? They have a 2. So 2 times what makes 2x? X. And 2 times what makes 10? Positive 5. So the answer to this is 2 times the quantity x plus 5. Make sense? Try the next one. If I want 6x minus 8, I know I can multiply what? 2 times what makes 6x? 3x. 2 times what makes negative 8? Negative 4. 2 times 3x minus 4. All right, do we still need to use the box? Is it helping? Any feedback? Yeah? Continue? All right, so there is no greatest common factor between 5 and 2, but there is among the variables. What is it? They both share an x. X times what makes 5x squared? 5x. X times what makes 2x? Positive 2. So my answer is x times 5x plus 2. Last one. All right, what does x squared and 2x share? X. X times what makes x squared? X times what makes 2x? Positive 2. X times x plus 2. Questions, anyone? All right, so pencils down. I just want you to pay attention to this because we're going to finish this up probably tomorrow. Okay, so if I have 25a squared plus 50a, and I say that my GCF is 5a times 5a plus 10, is this correct? Is that the greatest common factor of this? Let's check. What are the factors of 25a squared? 5 times 5 times a times a. What are the common factors of 50a? 5 times 5 times 2. 25 times 2 times a. So what are the common factors between the two? 5, 5, 5, 5, a. So the greatest common factor between these two monomials is 25a. But we don't have 25a here. We only have 5a. So couldn't I further simplify this? So if I have 5a, what can I pull out of 5a and 10? What do they both have in common? A 5.